Welcome, software engineers, to day 13 in CSC 222 software engineering. Thanks so much for joining us again. Thank you for the connection here via Zoom. I do sort of wish that we didn't always have to do a Zoom meeting. It's kind of funny. I teach a graduate class in ethics, computer ethics. We've been having a discussion about virtuality, dealing things online, because I have a number of students who are online there too, and just missing some of that physical presence. I just like, when did the word physicality come into the lexicon? You know, they started saying that on football 10 years ago. Physical, is that even a word? But there's something about being physically present that works out really well. I'm sorry we can't do that. So I'm going to stop pretending and we'll just go back to our 50 slides of pure excitement. Today, CNCS 5 is due. If you missed that, work on that, get that into me. Today also, it's all coming in at once. Assignment 13 is due. Excuse me, I worked with a couple of you with some questions. If anybody has a question specifically about some aspect of the code, I'd be happy to work with you. If we had time, I could share some of my code with you. But for those of you that got it taken care of, you wouldn't really need that. Assignment 14 is, and we'll go to Blackboard, we'll look at these things. Assignment 14 is that second article by Fred Brooks. That's due Monday. That's due Monday. And our CNCS assignments, Christianity and computer science, right now we're on a Wednesday to Wednesday type of thing. So we did the fifth attribute, the fifth commandment, that's due today. Today we'll begin talking about the sixth attribute of professionalism in the context of the sixth commandment. So if for some reason Blackboard isn't showing you this, shows it to me, but who knows? Here's just another way to know what's up, what's coming, etc. Oh, here's a surprise. Yeah, as a matter of fact, I'm not going to give up on this. I want to make sure we all understand what software engineering is. And I start every day this way, but you notice during the course of our discussion, we fill in some more details of what management really means. And not just via the Dilbert cartoons, but talking about other aspects of software engineering. I couldn't do any work this week because my project doesn't have a charge code. The chargeback group won't answer my email, and our ethics rules forbid me from using a false code. It's another failure of management, but I know you can do better next week. Would anybody, yeah, I think some people anymore would lash back out at their managers. Yeah. Another way to think about software engineering, to distinguish it maybe from other computer science activities like coding, is to describe it as professional problem solving. So thank you for allowing me to share some aspects of professionalism with you. See, I have it in my notes here, but I can't see my notes the way I'm displaying it. And last time I had a good suggestion. Rather than being cool and calm, was it collected? No, that's not it. It was, anyway, I got it written down. And odds are I will make that change, but probably not this semester. See, I'd like to take your ideas, the good ones anyway, and then claim them as my own. Never have to give you it composed. Thank you, Ryan. Yes, exactly. Good. So now I never have to pay royalties on any of these good ideas. The new one that I'm going to introduce today is being dependable. There are absolutely some connections and some overlaps between these aspects of professionalism, but I do want to single some things out. Number 6, being dependable, dedicated, civil, on time. I bet there's better names for all these things. Team player, composed, dependable. I am going to relate each one of my aspects of professionalism to one of the commandments. Now, if you know what the sixth commandment was, even before I got here, you're wondering how in the world is he going to relate that to that? Don't forget, if you're coming from a Christian religious tradition, other Christian groups number the commandments differently. There was nothing put on the tablets of stone that came down the mountain that said, this is the first commandment and the second and the third. All right. So this is the way Martin Luther numbered it. It's good enough for me. You shall not commit adultery. Next time we'll look at the explanation of that, and it might be a little easier to see this whole idea of being dependable. But let me use a couple synonyms for dependable. By dependable, I do mean reliable. And you can see how the idea of adultery and the relationship between a husband and wife, dependability, reliability, might go together for you. I'll get that information to you by Tuesday. You seem unreliable. I'll schedule some time on Wednesday to hound you and more time on Friday to escalate to your boss. You trying to be a jerk? I'm experienced. It looks exactly the same. Another synonym for dependable would be trustworthy. I think in the context of the commandment, that is even more of a connection, that trust between husband and wife. Boss, we're not planning any changes. Trust me. Trust you? I've seen your browser history. I wouldn't trust you to guard a funeral. And then it just deteriorates from there. So being dependable, whether you think of that as being reliable or trustworthy, think about that for now. I'm sure you can see how that is an aspect of a professional. And next time I'll talk some more about how to relate that to the sixth commandment. So we've overviewed design. So next major topic, some design principles. What are some of these guidelines or heuristics or rules of thumb that are going to help us to design? And we don't want to just design. We want to design well. Don't forget, let's review what design is all about. Design answers a couple fundamental questions. How the product will solve the problem. Design is all about how the product will solve the problem. From a computer science focus, here's where we plan the algorithms and the data structures. And as we saw last time, we're not just saying, okay, well, maybe it's a linked list, or yeah, maybe we're going to sort here. It is very detailed. It is detailed to the point that a coder, a programmer, who has no idea of the requirements or specifications or the problem or the project could take the design document and actually instantiate it in C#. So I can take a design document and I can create the code. If you just write sort in the design document, now you're forcing the programmer to figure out what kind of sort, what's the structure of the sort, and all those kinds of things there. So that's why it needs to be detailed. PDL, the program description language that's used for the planning of algorithms and data structures, isn't code. And there's still some work that the programmer is going to have to do to change the outline of the algorithm and the outline of the data structure into actual grammatically correct code. Oops. Okay. Ignore the back one. I just want the forward one. So what's good design? I've tried to avoid this and with you guys, but the campus of Mequon knows that all my analogies deal with cars. And no doubt I've done that already in this class. So what is good design? Well, if I haven't shared with you, my wife and I do own an older Corvette. This is a 1990 ZR1. Road America is the local racetrack. I'm blessed. 45 minutes from my house, I can drive to a world-class racetrack where they hold F1, GTL, real races with real race cars. So there I am. Pretty cool, huh? Now, it's not me that's good design, but seriously, and I think, yeah, I've shared this before, and some of you showed that you had very good taste too, because yeah, that's good design. The designers of this generation Corvette spent an enormous amount of time trying to make it a world-class car. Now, my car is 32 years old, so it's obviously not going to keep up with a current AMG GT or whatever it might be. But at the time, this was not only the fastest production car on planet Earth, it also recorded the highest cornering grip measured in G-forces. First production car to break the 1G cornering barrier and sustain speeds north of 190 miles an hour. So good design, good design. And it looks nice too. And hey, mine's red. You like that? Yeah, okay. Now, sometimes it's interesting to learn about good design by looking at bad design. If you own a Yaris, okay, well, I'm sorry, but that thing is just, okay. There are some cars that start off well, like a Porsche 911, and then people do something to it. No, not good, not good, okay? This thing, no. That was actually the prototype for something that does exist. This might even be better looking than that thing that currently does exist. Are they serious with these things? Those are ugly. Ah, that's much better design. Okay, sorry, can't help it. There's just some things that are aesthetically pleasing, but beyond that, and here we could legitimately say, but beyond the aesthetics of these things that are all just horrible, there's other characteristics that we design for also. What are the specifications? Is it designed to get the best possible gas mileage? Well, then maybe it's good. That's just not good. Yeah, that has a couple issues. Like the little horse down, it's a Mustang. And yeah, that's I like that one. Okay. This last one I brought in, this was an actual, this was a mass-produced car by Volkswagen in the 1970s, 1980s. It was called the Thing. I'm not joking. The Thing. And this is not a thing. Okay? If you're into automobiles at all, if you go to a current car show and people open up their hoods, all modern cars have plastic on top of their hood, on top of the engine. You can't really see the engine. It's all plastic. Well, no. That's not good. Okay. Mine is an all aluminum engine. There's real stuff in there. I open the hood and people say, "Ooh, that's pretty." Thank you for saying that. On the other hand, people look at things like that and say, that is not pretty. That is not pretty. That is not pretty. Does that look like me, do you think? My hair is grayer. So it looks like a thing a college professor would tootle around in, right? All right, sorry, enough of that. I mentioned last time, by way of review, that you should be testing at every phase. We don't wait until after we have created code, after the instantiation phase to test. You can test at every phase. There are two concepts associated with testing: validation and verification. You either read about that in the text already, or maybe it's something coming up right now. Validation is something that happens at the beginning of each phase. And it asks the question, am I doing the right thing? Validate. Am I doing the right thing? How do you validate design? You validate design by, by comparing it to the specifications. So before we do design, we review the specifications. The specification is going to say, what? I want to make sure that for every what, for every function that's specified, I have a how to implement that function. So this is validation. It's testing. You might be thinking, well, wait a minute, we just did the specifications, now we're doing the design. Yeah, but see, in many projects, larger companies and team projects, the people doing the design may not be the same people doing the specifications. That's often the case. When I worked in industry, my usual job was either as architect or something similar, and that's part of design. I didn't do the specifications. Somebody gave me the specifications. So now to do the design, my first job was to carefully review the specifications, because that would tell me exactly what is needed so I can then determine how to do it. Validate, testing that happens before a phase. Look at the previous phase to ensure that you know what you're doing in this phase. Yeah. The term module is a general term. It comes, well, it actually predates object-oriented programming. It comes from something called structured programming. A module is a unit, a structural unit of my software. We would use terms like a method, or a little more general, an object. Methods and objects are modules. In the bad old days of software engineering, people would create huge monolithic code. It's kind of like what we're doing in our individual project. Now, although it seems to us, seems to you, like there's a lot of code there, a couple hundred lines of code is really a small program. Production programs are hundreds of thousands of lines of code long. If you wanted to write a production program and just start at the top and went to the bottom in one big chunk, that'd be horrible. It makes sense. And I know in other computer science classes, you've learned the advantages of breaking down things into smaller units, breaking down this big monolithic code into modules. So whatever term you're going to use, I'll hear computer scientists talk about components of a program, objects, especially if it's an OO language, methods, functions, procedures. Those are all just more specific names for the general term of module. What's a module? It's a contained piece of software. Contained by us, the program. It's a contained piece of software. Oops, better wait a second. What are the advantages? Why would I break code down into smaller segments, into modules? Is that important to do? Does anybody really care? So note that we're talking about design. We're not talking about coding. We're not talking about instantiation. We're not talking about writing C#. We're talking about organization of our design here. Aha. What are the advantages? Well, surely things you've heard in other classes. Modularization provides easier creation. First of all, excuse me, it's easier to create a big program if we create it in modules. Some other terms that may be thrown around that you may have heard, stepwise refinement. And alternatively, if you're developing software as part of a team, then modules make it logically easy to divide the workload as a team. You're going to do the module that inputs. You're going to do the module that outputs. You're going to do the module that stores. You're going to do the module that sorts. We can divide up the workload as a team, both in design, as long as the architectural design is done, then the high level and detailed can be done separately, and also in programming. Yeah, cool. So easier creation. It makes for easier understanding of the code. That's important not only for the programmer, but it's also important later on in maintenance. And then it's also important in design, because design is also a team effort. And it's easier when we can just deal with smaller blocks of things rather than one big monolithic structure. Okay, I already mentioned maintenance. And this will also make it easier to extend the product, add things to it. And we'll see that is part of maintenance later on. So using modules is advantageous to software engineers, beginning in design, going into instantiation, and then all the way to the end in maintenance. It carries with it benefits. All righty. What makes a good module? There are two characteristics, two concepts that software engineers have identified that help us assess whether a module is good or poor. What makes a good module? Now, these are heuristics, they're guidelines. It's not a hard and fast rule. There's not an algorithm that can run and say, well, that's a good module and that's a bad module. These are the two ideas that we want. When you're thinking about modules, when you think about designing modules, you want to maximize the relationship within the module, and you want to minimize the relationships between modules. We'll see some examples and we'll put a term with these. You want to maximize the relationship within a module and then minimize the relationship between modules. So these are the general guidelines. This is what software engineers say when you're designing how to know, should I make this a module? Does it do two things I thought were a module? Should they be combined? Or one module, should it be separated? Here are the guidelines for that. Now, the two software engineering terms are, first of all, cohesion. Cohesion is a measure of the degree of interaction within a module. So what did we say before? We want a maximum relationship within a module. We want high cohesion. I think I'll write it down in a moment. Degree of cohesion is a measure. It's the measure of the degree of interaction within a module. Is your module focused on one logical task? The other term software engineers use is coupling. Coupling is the degree of interaction between modules. Are these two modules constantly talking to each other, sending parameters, looking inside each other, whatever? The degree of interaction between modules. And what do we want? We want to minimize that. We want low coupling, less coupling. We want high cohesion, more cohesion. We want low coupling, less coupling. Ooh, I wanted you to hear this from the man, but I don't know why. Suddenly, PowerPoint is not allowing me to break out and show other things. Haven't we done this before? I don't know. Office 365, it's always updating. There's probably a switch somewhere I've got to throw to allow me to do something. I know you can't read that quote. It's just a screen cap from the thing here. But Fred Brooks is actually still living, and he's one of 3 people older than I am on planet Earth. So he's pretty interesting, but you'll just have to read about it. Read about it. So to review what Dr. Brooks said, we want high cohesion, maximum relationship within a module, modules with a high degree of interaction within them. Or another way of thinking about it is we want modules that are focused on a single task. If you design a module that is going to, let's say, validate the input and print a label and produce the help message, and that's not focused on a single task. That has low cohesion. Now, can you design it that way? Sure. The problem is it's going to make the implementation a little more difficult, but this is what we're looking for. All right. So here's my example. Here's my add nums module. Here's my add nums method. It's going to, within it, say, let's input some stuff, let's add some stuff, let's output some stuff. An example of a better module with high cohesion is my module or method called compute. Notice that it is creating a running total and it's dealing with a count of shims. Those two things go together. In design, they logically do, right? Because every time you add the weight, you're incrementing the count. Those are connected in the job and the task. All right. So if we wanted to go back and break up that first one that said add nums, if you have a module that's accepting data and you input it and you validate it, those two ideas go together. They absolutely do. And that's good. To summarize what Dr. Brooks said, we want modules with low coupling. That's the degree of interaction between them. Modules with a low degree of interaction between them. Oops. Oh, yeah. Well, there were some examples that you didn't see, but it's just, do you have 2 modules that are constantly calling each other, passing different things at various points within their execution stream? They're kind of tightly coupled. Don't want that. We're a little bit early. Is it too early to stand up? We're going to be doing that, but I'm going to rely on you to remind me to do so. I remembered this time. Martha, Seb swallowed 5 toy horses. Mabel, oh my goodness, that's awful. What did the doctor say? Well, the doctor said the doctor said his condition is stable. Horses, his condition is stable. Sometime I'm going to make you turn on your cameras. I'm going to make sure everybody is laughing. All right. Should we do the stand-up thing? Okay, let's do it. I'm going to turn off my camera because when I stand up, then suddenly my virtual background goes away. You like that background? That's kind of cool. Okay. Okay. Now, you ready? Stand up. Ugh. Are there any health benefits to standing? There are. Standing improves cardiovascular health. Rather than being an unnatural act, at one time there were therapists and physicians who said, well, no, human beings weren't designed to stand or something like that. No, rather than being an unnatural act, standing is actually a perfectly, in other words, we were designed to stand. Always cracks me up that some folks talk about, well, humans developed through an evolutionary process and your back isn't designed. No, your back is designed perfectly well for standing. So don't buy it. So don't forget to stand. You wouldn't go through a day without standing, would you? Okay. As you notice, I just don't like dead air time. So we'll just talk about it. Good. Did you stand up? Thank you for doing so. Here I am. I'm back. Oops. Martha.
Here's some information.
Okay, sorry. I don't know what, hey, I don't know what keys off my speech rec. I know what words I use to get it started, and I'm not saying anything like that. Okay, now I was going to say the joke again, but now it's all ruined. Onward. What separates a software engineer from a coder? There's a number of attributes, but one of these is this. A software engineer needs to think ahead and anticipate possible problems. Think ahead and anticipate possible problems. Programmers, coders don't do that. That's the job of a software engineer. And it's a very important job when you're creating an actual software project. Now, again, you can help me and I'll steal your terms. I don't know what software engineers think ahead. They plan ahead. They anticipate possible issues. Those are, I know the ahead idea, that's just a colloquial phrase. Think ahead, consider, ponder what might go wrong. That strikes most people as weird. Wait a minute. Software engineers should sit around and think about what could go wrong? Yes, because it's very likely that it will. So set one point of separation between a coder and a software engineer is this. Software engineers have to anticipate issues. Now, where does that fit in here in our taxonomy of good design? It actually fits under point 2. So we mentioned that good design meets specifications, like my ZR1 Corvette, works well, like my ZR1 Corvette, aesthetically pleasing, like my ZR1, Good user, yes, like my car does all these things. Robust is the computer science term that we're focusing on. Robust means it works well even with erroneous input, or works well in spite of unanticipated input. That's why the very first time we did ad nums, I had you do a try catch. Let's make sure that if something goes wrong, we know and we can respond. So in other words, we were planning ahead just in case it failed. How will it fail? And what do we do about that? Okay. Robust is a computer science term. Works well in spite of erroneous input, unexpected input. The book by Henry Petrosky, entitled To Engineer is Human. Now, Petrosky was writing more from a civil engineering perspective. I don't know, 1,000 miles or so north of you, maybe more than that, up at the tip of Washington State, outside the town of Tacoma, Washington. This is the Tacoma Narrows Bridge, which I've driven over. Not this one, because this one was in the midst of falling down, but the new one that they put up. At the time that this was built in the mid-20th century, it was kind of an engineering marvel. You can see it's a suspension bridge like the Golden Gate. But some folks didn't anticipate something. If you've lived in Washington or been to Washington, you know it can be quite windy at times. And especially in the Tacoma Narrows, which is kind of a natural wind tunnel for lots of gusts of wind. Well, they did not anticipate the size of the gusts nor some other factors there. And one day the bridge started vibrating in harmony, and it got worse and worse and worse. And it was going up and down and up and down, and it finally tore itself apart. The subtitle of Petrosky's book is The Role of Failure in Successful Design. So in order to design well, you have to understand failure. In his book, he says success is really foreseeing failure. That sounds totally counter-opposite. Totally counter-opposite. It doesn't say you want your product to fail. It says you anticipate and you plan for potential failure such that your product will ultimately be a success. Does this one work? Why would this one work if the other one did not? Should I break out? No, I won't do that. Anyway, they're just interesting. While none of them directly apply to us as software engineers, they all do indirectly in the kinds of mental habits that you need to develop to be a successful designer. Darn. Today, well, I shouldn't say that. Many automobiles have a smart key. Before automobiles had fobs and no keys, there was the smart fob. So there was an actual physical key, but then there were some other things on it. You can see on this key, there's a lock and unlock and a panic button. Now, what's interesting is originally, when these came out, after a while, they figured out what to do. But originally, if you put the key in this way and put your thumb on the front of it and turn the key, the odds of you hitting one of those buttons were really high. And if you did, the command went. If it was lock or unlock, well, I suppose that'd be surprising. But if it was panic, such that your horn starts going off too, yeah, what could possibly go wrong? Well, Everything was redesigned such that when it senses that it's actually in the ignition, then those buttons are disabled, at least during the cranking process. Foreseeing that, yeah, maybe that was kind of hard, or was it? So the job of a software engineer is to think ahead and say, what could possibly go wrong here? Is this all okay? Is this, you know, this is staged, right? And surely that circular saw is not moving. Yes, thank you. Unlike a programmer, unlike a coder, a software engineer has to consider, what if the user does something unexpected? Programmer doesn't think like that. The programmer says, okay, this is asking for a number. The user is going to input a number. Not necessarily. What could possibly go wrong? We saw something like this before with the user interface. If your user interface looks even remotely like an airplane cockpit, then you're doing it wrong. There's why, dude, yeah. You're saying, oh, sure, this is just, no, not good. So what should we do as software engineers? First of all, we need to understand user errors. And secondly, we need to plan for user errors. Did you know there's a whole science of understanding user error? Yeah, there's a lot of good psychology about user errors. How am I going to show you the video? I moved the meeting to Tuesday. I can't make it on Tuesday. Somehow I think the marketing team can survive one meeting without engineering support. We'll include a pet gerbil in every box. We just need to make sure it's in a sealed plastic bag so it won't chew on the cables. Understand errors and then plan for errors. There's a classic book on this written by Don Norman. Yes, thank you, Don Norman. Donald A. Norman. Don Norman, although not specifically a computer scientist, served as an Apple Fellow. Is he still an Apple? Well, yeah, once you're a fellow, you're a fellow. But I mean, is he a working Apple? I got to check on that, see if he's in day-to-day Apple design things. Don Norman wrote a classic book called The Design of Everyday Things, not focused on software per se, but the general gist applies to us too. And in that book, he talks about the psychology of two different kinds of errors. Understand errors, plan for errors. Let's understand errors first of all. And these are called slips, mistakes. Those are two different ways that people can make an error. Slips, mistakes. Okay. Yeah. Darn, I wanted the Norman people to tell us about this. We'll fix it next time. So let me tell you, we can't just review it. Let me tell you, what's a slip? A slip is something defined at least in the video, they defined it as either automatic or subconscious. What's an automatic mistake? I'm sorry, an automatic error or a subconscious error. This is how it's explained. A slip is when you knew what to do, you inadvertently did something different. You did the wrong thing. Oftentimes happens when we are distracted or mentally overloaded. Has it ever happened to you? Every once in a while, I want to drive somewhere and I know where I'm going, but suddenly I just go on autopilot and rather than taking the turn left to go to church, I go straight because that's where school is. Well, yeah, you were a little distracted by something, or you just weren't paying close enough attention. A slip is a subconscious, semi-automatic mistake. You intended to do one thing, but accidentally did another. Do you think this ever happens to computer users? Has it ever happened to you using a computer system? You intended to do one task in the app, but you misclicked, didn't think about it, hit escape, hit enter, whatever, and did something else by accident. Yep, it happens. Example. No, I had to see what their examples were. Okay, yeah, I can give you an example. Does it ever bug you that when you delete a file or when you try to exit an app, it says, do you really want to do that? Why is that? Because that's how they catch slips. You know, delete. Yes, delete, yes, delete, yes, delete, yes. No, not that one. You just kind of get in the habit of deleting a bunch of files and then you mistakenly delete one. Or, you know, you had a fat finger and you meant to touch whatever and you touched exit. Yeah, it probably makes sense, right? So how do you catch them? Confirmation messages. In the world of software, the dreaded confirmation. Are you sure you want to exit? Do you really want to do this? Really want to delete that file? Those are designed to catch slips. Good. So we understand them and we know how to plan for them. What do you suppose? Is that real? The other type of error is not a slip, but Don Norman and others of us identify it as a mistake. Unlike a slip, a mistake is a deliberate, conscious error. And again, you'd say, wait a minute, why would somebody deliberately make an error? Well, no, that's not it at all. The conscious aspect is you didn't understand what the app was asking you to do. You spent some time thinking about it, and then you deliberately made a choice. It just so happens that choice was the wrong one. Psychologists refer to this as inappropriate intention. What was your intention? I'm not sure, because I didn't really understand what I was supposed to do. Okay. Do I have it here next? Yeah. Poor wording in an early version of the COVID-safe contact tracing app led people to incorrectly believe they had contracted coronavirus. Users were presented with a message stating, you have tested positive for COVID-19 if they touched a button for uploading their data. Okay. Yeah, that could be somewhat confusing. There's all kinds of examples. I'm sure you can find some too. The idea is, hey, I read the message, but I really don't get what am I supposed to do here? We remove from file app. This procedure will be offered to you only once. Oh, and then please restart after this alert has disappeared. Would you like to copy all the files that were located in your disk8 folder to your documents folder? I don't know. This is a classic one. And it's hilarious that it said, well, yeah, no, it's just, this is by design. We wanted to make it confusing. Well, thank you very much. All right. We'll come back. I absolutely want to at least show you that one last video there talking about slips versus mistakes, important for you to understand as software engineering students and also to apply later as software engineering professionals. We've talked about the various phases in the software development lifecycle, and I want to approach them from a slightly different way. The front end, and that would be the two phases of requirements and specifications, that's all about analysis. It's an analytical process. You break up something complex into something simpler to understand it. I want to understand the problem. I want to understand the features. I want to understand the functions. That's all analysis. Requirements and specifications, the front end of the software development lifecycle is analysis. Well, what happens after that in the so-called back end of software engineering, in design and instantiation? That's a synthetic process. Synthesis is to build up something, to create it. Synthesis is to build up. And yeah, design and instantiation are a building up process to ultimately solve the problem. Analysis versus synthesis. Next week, we're going to begin our foray into team projects. We're not done with the individual project, but I need to I'll explain. I need to hold off on that just a little bit. So there's still a little bit more to do on the individual project. But beginning next week, we're going to start the investigation into a team project. In a typical semester, I do one of two things. I ask for folks around me, do you have any desktop-based app that a team of students could produce? And those have worked out pretty well in the past. Other times, I just dream up a bunch of stuff to have you do. I did this once in the past. I'm going to try it again. If you can think of a good desktop app project, in other words, that's what we're going to focus on. Focus on the same thing that we did as the individual project. We're not building a web app. We're not building a client server app. We're not building a mobile app. We're going to build a good Windows desktop application. If you have a suggestion for, now I've got some, so if I don't get any, it's not a problem. If you have a suggestion, and you'll have to think about this, I think, email that to me. And if I think it's good to the point where it could potentially be used, either this semester or in a future semester, I'd be happy to give you some extra credit for that thought process. This is very much an analytical thing. Got to do some analysis, got to think about it. Suggest a good project, and I'd be happy to give you some extra credit if you do that. So feel free. I mean, you could send it to me. If I don't think it's good, I won't punish you in any way. But the good ones for extra credit. Now, also in the past, I almost always, one time I allowed folks to self-assemble into teams. That was a pure disaster. So I almost always appoint teams. The typical team size is 4. 3 can work. 5 is totally out of hand for reasons that you can probably deduce now that you understand Fred Brooks' Mythical Man Month. 4 might be pushing it, but there are 28 people in class, so that gives us 7 teams. And that's a lot to try to do and track anyway. If there is someone you would like to be on a team with, feel free to email that to me. Note, no guarantee that happens. because I also have some things in the back of my mind of how I want to structure teams. So, but if there's somebody else in the class that you'd like to be on the team with, feel free to email that to me. And I'll try to work that into the mix also. By the way, the project one, you have a little bit of time, but this one here, if this applies to you, I need to know by Friday. Send me an email message by midday Friday, because I want to try to structure things over the weekend. Cool. Next week will be a little bit different. Next week, I'm away at a conference. I am presenting at an international conference in St. Louis, and something I'm excited to do. Something I don't do a lot, but in the vocation of college professors don't just teach. They are expected to do other kinds of things, including research and then presenting on that research. So I don't do this very often, and I turn down a lot of these things just because I don't want to, be away from the classroom. Now, you might want me away from the classroom, and I understand that. And that's going to happen next week. Monday, I'm going to try to zoom in for part of our time at the beginning. Okay? There's a presentation happening at Central Time and St. Louis Central Time too. This class begins at 6:10, and I've got something happening at 7. So it had to. Now, if I can zoom in, depends on a couple things. It certainly depends on what kind of technological infrastructure is either at the conference site or at the hotel or wherever it is. Okay? If it's 2 kilobits per second, probably not going to happen. But I'm going to make every effort to be with you on Monday. I'm going to post some things on Blackboard. So be sure to take a look at Blackboard, because it will tell you, and I'll try to update that and let you know if you need to zoom in here or if you need to do other things. If I can't be with you, there'll be some things to do. Next week Wednesday, we can't meet. I'm sorry, we just can't meet at all. So I'm going to allocate that time for having you guys meet as a group. I think I have it set up. I think you can join this meeting room without me. I think I had it set up that way. I'll double check. The only bad thing is I don't think you can set up breakout rooms, which is what you'd need to do to separate yourselves. I'll see what I can do about that somehow. And maybe you just have to figure out a way to Zoom with each other on your own personal Zoom room or something. Or maybe you can all meet physically. That'd be good too. I'll post this on Blackboard, but just so you've heard it once, next week will be a little bit different. Oh, wow. I don't think I shared this with Professor Tallman. I think I better tell him. Monday, I'm going to make every effort. We'll do some stuff, at least for the first half of the class. Wednesday, no way. But there'll be some things to do related to the team project and team members. All right. Do you have any, well, I'm going to do one other thing. I think that's it for today, right? Yeah. It's not technically the end of 2022, but it's the end of this day. Any questions, comments, or concerns? We're not done. 2 other things we need to do. So at least for me, again, because I know I've had some folks saying, I don't know when things are due. I think it's telling me here. Okay. Now, here's the problem. I said assignment 13 and CNCS5 are due today. Well, if you set Blackboard to be due today at the end of the day, 11:59 p.m., it just, for some reason, it thinks it's tomorrow. So today, thank you. Yep. Not only tomorrow, but this week. So there's the ones we've talked about. And here's, where are the other ones? Future, there's supposed to be 4. Oh, I don't know how to get them. Oh, I know how. Scroll. There we go. If you're looking ahead, I just didn't bother to hide these things. Those are the CNCS assignments in this unit, and you're certainly free to work ahead. In the context of that, let me say, for a couple folks who were missing an assignment or two in the past, a couple times ago, I mentioned I'd be willing to accept these. So please submit them, but please talk to me about that. So thank you for doing that. There's one caveat, and if it wasn't clear, if it comes in late, I may not be able to grade it quickly. I hope you understand. I have things set up such that I have the time to grade this and grade that, et cetera, et cetera. When things do come in late, that's why my official policy is I don't want to accept late assignments, because either you're upset because it's going to take me a week, 2 or more to get to it, or now I'm pulling myself away from other tasks to grade old things. I'm going to do it. I said I'd do it. So if you were missing an assignment, you emailed me, I said, okay, but thank you for not saying, hey, are you going to grade this anytime soon? I will. Anything else we need to look at Blackboard? I mentioned to somebody who had a question about the course casts, and probably because that's just a weird term. If I use the term course cast, I'm just talking about the videos of the recording. Right now, I'm recording this, and then afterwards, I post it. So I know you don't see October 5th right now because we're doing it live. Once it's done and processed by Zoom, then I'll put it here. But if I said, hey, look on this date because we talked about this aspect of the individual thing, or I showed some code there or whatever, and I apologize if I use the term course cast, that only means something to me. For you, and what I called it on Blackboard is the course videos, but you do recognize they're all there. Have at it. You want to review something? Go for it. All right. The other thing that was asked is, my readings got a little bit off because of Labor Day, and I didn't want to redo everything. So week 7, actually began sort of in the middle, but you'll read it anyway. You can figure it out. Good for you. There's the article, the No Silver Bullet article. That's what's referenced in assignment 14. When it says the link above, yeah, it means that one right there. All right, I think I've answered all those questions. Any other questions about assignments or Blackboard or weird stuff like that? One final thing then. If you have any questions about code, I'd be happy to do that up to a point. I mentioned up front that, our focus is not really on coding and programming. The flip side of that is I know that the Visual Studio environment is a little weird, although I think many of you have used it before. And secondly, C# might be a little different, although as a C-like language, it's not like it's a weird thing here. It's not Scheme or Algol or something weird. Be sure that right up front, you have a meaningful comment. Now, should it be above your compiler directives? Should it be within your namespace? Should it be within the class? I don't care. But, don't put it buried in the middle with some module somewhere. Right up front, I want to see your name, the date, and the purpose. At one time, the purpose was just to produce a running total, but we've expanded that. In other words, every time we've added a feature and you've added functions to your code, you should be talking about that. So there's more to it than just adding things, right? So good comments are helpful. And then the question always comes up, well, what about comments in line with the code? First of all, a good comment explains why you are doing something. You don't have to tell me what you're doing. Just tell me why you're doing something. The general heuristic or guideline is every object should have a comment that expresses the purpose of that. Now, to what level, etc., that depends on a lot of factors. This method will be utilized throughout the program as the array list history holds all the previous entries. Calling this method will add all elements within the array list, blah, blah, blah. Okay, good. Now, the question comes up, do you comment each line? No. Do you have to comment control structures like this repetition, like this for? If it's non-obvious what's happening, yeah. If you're using good variable names, then you probably don't have to explain what they are. If you're using bad variable names, don't do that. Use a good variable name. So you can see that anytime I have a method with anything at all, there's some level here. Good. Where's my, I'm going to point out one other thing. This is, I'm using an array here just as a very simplistic structure such that I can do multiple levels of undo. You didn't have to do that. You could have grayed out the undo after one. So I had to do is just remember statically one thing and remove that. But then this allows me to do that. And I know some of you are using some structures. I've seen it in assignment 11 and other things. And yeah, you're probably keeping track, right? I mean, whether you have an array or you're using a stack, a stack would work. You're using a linked list. You're going to have to check and make sure. Don't allow the user to delete once it's empty. Once you've deleted the very first thing put into here, you can't delete anymore. So you're going to need some code to check for that. Some folks, and this is partly my fault too, because I said use a pop-up window. And there is such a beast in Visual Studio. But if you're having trouble figuring out how do I get parameters into that window, especially if you have it in a completely separate section of your code, that's a little hard. It's okay. You could have used a message box, and that's exactly what I did. My print function just brings up a message box. Yeah, there's a lot of stuff to put in there, but that's okay. Not a problem. A message box works rather than having a completely separate form. And then you got to figure out, how do I pass the parameters between, is it a private? Is it a public? How am I doing that? The write out I mentioned here, you could either, and this is just the code that you saw, but just a few changes to it. You could have either specified the location where it's going, like docs or my docs, whatever it is, or this one here, I used the save as window, and the user could specify things. Fair? Good. All right. Any generalized questions on coding? If you got a specific one, like mine doesn't work or whatever, I'd be happy to look at that with you. Any generalized things? Here, I'm big. Kyle and Andrew, you got your cameras on. Good for you. Good for you. Keeps you engaged. Some classes I ask people to do that. Other classes I think, oh, hey Timmy, Good job. Now everybody's good. You don't necessarily have to do it. It's okay. I do appreciate that. It's just hard. This is hard. All right. So folks, check Blackboard because there'll be something different happening next week, but I'll alert you to that. Plan on zooming in Monday but not Wednesday. There'll be something posted to do. So generally, we're done. I'm going to stop the recording in just a moment, but if you have a question and want to hang out here, I'll do that for a little bit. So have a nice day. Have a happy weekend. I'll see you virtually next Monday.